All right, let's really try to focus here and pay attention to the explanation about radian measure. Now, up until this point, we have been measuring angles in a measurement called degrees, right? Everyone's familiar with degrees. We all know that this is 90 degrees and this is 180 degrees and, everything like that. So 30 degrees, 60, 90, right? All right. So we're familiar with what those type of angles look like. If I tell you 90 degrees, you have a visual in your head of what that looks like. If I tell you 300 degrees, you kind of know what that looks like. You know it's almost all the way around the circle, but not quite. It's in the fourth quadrant, right? So we're familiar with that. We are now going to get into a different way to measure angles that we have to learn about. It's called radian measure. So we already know degree measure. Now we're going to do radian measure. In order to talk about radian measure, we have to first learn about what a radian is. What is a radian? So I'm going to use these diagrams here to kind of explain to you what a radian is. Do the best I can here in the video, and I may have to do a little better explanation individually in class with you, but let's try and understand this. So I have three different size circles here. Three different size circles. See that? Now each circle has a different radius. This circle has a radius of 1 centimeter. This circle has a radius of 2 centimeters, and this circle has a radius of r centimeters. That means I don't know how long. It might be 3, it might be 4, it might be 5. But the bottom line is, if this is 1, right, this must be 1. And then if you go this way, it's 1. If you go this way, it's 1. Every which way you go, it's 1. Because that's what a radius is, right? Doesn't matter where you go. 2, 2, so on and so forth, right? If this is r, then so is this. Okay, does that make sense? A radian, and I'm going to mark these angles here. This angle, this angle, this angle. Okay? They're all the same angle. The only thing that happens is the radius gets bigger. The space there, that space, okay, that space in between, the angle measure is the same in all three circles. The angle measure for each of those angles is 1 radian. 1 radian. Radian measure, unlike degrees, degree measures are larger numbers, like 30 degrees, 40 degrees, 100 degrees. You're not going to see 30 radians, 40 radians, 100 radians. You're going to see very small radian measures, and I'm going to try to explain why, okay? This is only 1 radian, this is only 1 radian, this is only 1 radian. The reason why it's only 1 radian, listen carefully, the reason why it's only 1 radian is because in order to make that angle, if you go along the circle, right there, right there, right there, okay, see that length, that arc length along the circle? Or that one, see how that length gets bigger, gets bigger, gets bigger? But it got bigger, but remember, so did the radius, it got bigger. All right, so when the length of the radius is equal to the length on the arc, that's 1 radian measure. So you see how this is 2, and this is 2, and this is 2, okay? That angle there is 1 radian. This is r, obviously, and this is r. So I don't know what r is. It might be 5 units, then this is 5 units. When this could be 15, then this would be 15, and this would be 15. It doesn't matter what the measure is. The point is, when the length of the radius is the same as the length on the arc, that space in here, which is known as an angle, the measure is 1 radian. So what's the measure of my angle here? 1 radian. See how it says 1 rad? 1 radian. So what's 2 radians? Okay, well, we're going to use this picture. If this length is r, and this length is r, and this length is r, and this length, curved length, is r, and this length is r, okay? And r could be any number. So let's give it a number just for the sake of argument. You don't have to write this. Let's say this radius was 3. Well, doesn't that mean this is 3, and this is 3, and this is 3, and this is 3, right? Just for something easy, a nice easy number to look at, okay? It could have been any number. I could have picked any number. Well, this angle, I'm going to change colors here. This angle right here, this angle that goes from here to here, see how it got bigger? It's bigger than the angles we were looking at up above. It's this angle plus this angle. If this is 1 radian and this is 1 radian, that big angle that I just drew, that red angle there, is 2 radians. It's 2 radians because there's 2 lengths of the radius. See how it's 3 and 3, whatever it was? It was 2 of those radian lengths. 2 of those lengths stops right here and makes 2 radians. Okay? So this measure, this angle measure is 2. What do you mean 2? That looks like, that's more than 90. What do you mean, Mr. Ventry? That's a big angle. That's more than 90. Yes, it's more than 90 degrees. But if you convert it to radian measure, it's only 2 radians. Okay? So that's what we have to think about when we're doing radians. Now, it turns out that to go all the way around the circle, any circle, it takes 1, 2, 3, 4, 5, 6 radians plus a little bit left over. It turns out that it's 6.28. It takes 6.28 lengths of the radius. Remember, it's lengths of the radius, however long the radius is, but going around the circle. It takes 6.28 of those, 6.28 approximately, 6.28 of those to make a full circle. To make, what's a full circle? How many degrees? 360 degrees. So that's the conversion. 360 degrees is approximately, that means approximately 6.28 radians. So you see how degree measure is going to be a lot more than radian? Think about temperature. You know how there's Fahrenheit and Celsius? 85 degrees Fahrenheit is 30-something degrees Celsius. If you hear on the radio in the summer, it's 85. Well, who listens to the radio anymore, right? It's all like satellite and like iPods and stuff. But anyways, if you listen to the radio, a Canadian station, and you hear it's 85 or 32 out, well, that's because 85 in Fahrenheit, 32 in Celsius. All right, so in radian measure, you're going to see that the radian measure is much smaller than the degree measure. And 6.28 radians, 6.28, the number 6.28 is double 3.14. And what do we know about 3.14? 3.14 is approximately pi. And that's what I'm trying to get at here, is that 360 degrees, it takes 6.28 radians there, okay? Half of 360 is 180, okay? And half of 6.28 is 3.14. So therefore, we could say that 360 degrees is 2 pi radians and 180 degrees is pi radians. And that's what we're going to kind of be using for everything we do. And the explanation, again, is maybe a little vague. You're not really sure. But again, if it takes 6.28 radians to go around the circle, 6.28 is 2 pi. So I'm going to write that here. 6.28 is approximately 2 pi. Why? Because pi is approximately 3.14. We all know that. So if it's 6.28, it's approximately 2 pi. If you double this, you get 6.28. If you double pi, you get 2 pi. Okay, so we're not going to use 3.14 and 6.28. We're going to use pi. because it's more accurate. These are rounded. When I said approximately 6.28, it's rounded. All right, so we're going to use pi for 180 degrees. That's the conversion. And we're going to use 2 pi for 360 degrees. That's going to be the conversion. All right, and you're going to get more used to this as we go along. So how do you convert from radians to degrees? Well, if 180 degrees is pi radians, all right, pi radians to 180 degrees. So we're going to convert from degrees to radians. We're going to convert from degrees to radians using this formula right here. Degree measure, if you have a degree measure, you multiply by pi over 180, and that's going to give you the radian measure. So let's do that here. Convert each radian, each to radian measure. So I'll have 120 here, and I'm just going to follow the formula. Times pi over 180. So I do 120 pi over 180. So all you got to do is leave pi alone because I want my answer in terms of pi, so I'm not going to touch pi. I'm just going to reduce 120 over 180. Zeros cancel. 12 over 18 is 2/3. So it's 2 pi over 3. 2 pi over 3. 300. And then you just go times pi over 180 because that's the conversion. And then 300 over 180, again, that reduces out. 6 goes into 30. 6 goes into 35 times. And 6 goes into 18 3 times. So it's 5 pi over 3. So that's 2 pi over 3, and that's 5 pi over 3. All right, so again, pi radians is 180 degrees, so here's the conversion, how you convert from between them. 2 pi over 3 is the same as 120 degrees. 5 pi over 3 is 300 degrees. Okay, so now down here, these aren't going to work out so nice because 140 pi over 180. And then I want to convert, we're going to say approximately because we're saying nearest hundredth here. All right, and I already did this. You just do 140 times pi in your calculator, literally the pi button, and then divide by 180. I already did it ahead of time just to save time. That's going to be 2.44. So what we say is it's 2.44 radians. Okay, I'm going to go back up here and say 2 pi over 3 radians. 5 pi over 3 radians. You should put the unit measure with it. All right, it's a good habit. And this one's going to be 307 pi over 180. And that's going to be 5.36 radians. Okay. Now, to go the other way around, if I know the radian measure, I'm able to go to the degree measure, and I just do this. So I multiply by 180 over pi. Instead of pi over 180, it's 180 over pi. So this one is 3 pi over 5 times 180 over pi. So now we're multiplying fractions, which we did earlier in the year, right? You just cross cancel if you have a common factor. Pi is a common factor, top and bottom. So pi's cancel. I get 3 times 180 over 5. And 3 times 180 over 5 is 108. You just put that in your calculator. This one, 2.4 times 180 over pi, and literally just put that in your calculator. We're going to do nearest degree. So I'm going to 2.4 times 180, 2.4 times 180, and then we're going to divide by pi afterwards. Okay, we're going to hit enter, then divide by pi, and it comes out to be 138 degrees. All right, that's just the conversion. And then the last thing in our video today is a shortcut to convert from degrees to radians. So here's what we know. We know that 180 is pi radians. We're going to base everything off of that. That's what we learned earlier in this video. 180 is pi radians. So that means that 90, which is half of 180, must be pi over 2. Pi divided by 2. 180 divided by 2. Doesn't that make sense? You just divide both of them by 2. So if I divide 180 by 2, I get 90. If I divide pi by 2, I get pi over 2. I can't do anything else. 60 is 180 divided by 3. Well, that's pi divided by 3. See, 180 divided by 3 is pi divided by 3. So we call 60 pi over 3. 45 is 180 divided by 4. That's pi divided by 4. 30 is 180 divided by 6. That's pi divided by 6. So these we can now use for anything. So if we wanted to do 150, for example, 150 is how many 30s? 150 is 5 30s. 5 30-degree angles. 5 times 30 is 150. So you factor it basically. 5 times 30 is 150. 30 is pi over 6. So we say it's 5 pi over 6. Okay, and that's how we get that. So we're going to do a few here. So 210 can be factored, right? 210 is how many 30s? 7 30s. It's 7 times 30. So that's 7 times pi over 6. 30 is pi over 6, and that's 7 pi over 6. That's a shortcut to converting from a degree to radians. 135 is 3 45s. It's 3 45s. You got to either break it down to 30, 45, or 60, or 90, okay? That's what you're going to factor it down to. So it's 3 45s. So it's 3, and what did we say 45 was? 45 is pi over 4, right there. So it's 3, I hate when that happens. It's 3 pi over 4s, all right? So it's 3 pi over 4. 3 pi, let me write that better. 3 pi over 4, okay? 300 can be broken down with 60 or 30, but 60 is bigger. You want to do the bigger one. So it's going to be 5 60s. 5 60s is 5 pi over 3s. Because 60 is pi over 3. Just look above, right? So it's 5 pi over 3. And then 420 is how many 60s? You could do 60 again. You could do 7 60s. 7 60s. 7 times 60 is 420. So you could do 7 pi over 3. 7 pi over 3. So 7 pi over 3 would be the same as 420. All right. Hopefully I'm making sense here. And then here's a shortcut for converting degree to convert to degree measure. Because we know that pi is 180, because we know that, if we're given it in pi and with the pi in there, you can literally just substitute pi. You could substitute 180 in for pi. So you could say 2 times 180 divided by 3. 360 divided by 3, that's going to be 120. This one's 7 times 180 divided by 4, and that's going to be 315. And this one's 5 times 180 divided by 6. Just use your calculator, and that's going to be 150. All right, sorry about the length of the video, but very important, very, 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 very important lesson, because everything we do from here on out is pretty much going to be radians. So you got to get used to this radian measure rather than degree. All right, see you in class.